Okay, 2012, number 3. They give us this nifty graph, and we could probably already can expect what's coming. They say this is the graph of f, continuous function. They tell us that there's some other function, g, that's an integral defined function. Be really careful. Look, it's from 1 to x. Okay, so there's our g. And then the first thing they want to know is g of 2. So make sure you write g of 2, you show the integral. And then we know it's a little triangle, 1/2 base height. So the 1/2 is easy. The base is 1, right, from 1 to 2. But then the height, what's the height here? They didn't give us a y value. Just use your knowledge of slope, right? It goes down from 0 to -1 if it goes all the way to 3. Do you see that? So halfway point, when x equals 2, it must be at -1/2. Okay, to follow the logic there. Goes from 0 to -1 over a change of 2x. So a change of 1x, it's going to go from 0 to -1/2. And so I get -1/4 for that area. Okay, and is it negative area? Yeah, it's under the x-axis. So it's negative area. Ooh, and then g of -2. I like these. G of -2, let's plug this in. And I get 1 to -2 f of t dt. Do you remember that oops, that's just dt. Remember the smaller number has to be on the bottom. So I'm going to have to flip this. So the only way to, quote, flip it in calculus is to make the whole integral negative. And then it's going to be -2 to 1. So now I can do it. So whatever answer I get, I'm going to stick a negative in front of it. So let's see. From -2 to 1. Oh, they weren't taking it very easy on us, were they? We're going to have to figure out this triangle and the half circle. So the triangle is 1/2 base height, and the height is 3. Oh, that's not too bad. So 1/2, a base of 1, a height of 3. So 1/2 times 1 times 3, plus this half circle. So pi r squared, right, for the area of a circle. It's going to be pi, and then the radius is 1. But notice it's a negative area. So it's negative pi radius squared, which is 1. I'll just write that so you can see it. Okay, and then when I finish that, I get 3/2 minus pi. But look, you've got a negative on it. And I think I would just leave it right here. That answer is correct. -3/2 minus pi. If you want to distribute the negative, you can. You have -3/2 plus pi. Same difference. Okay, probably to be safe, I would just leave it here. Okay, boy, we just got letter A done, and we knew how to do that. So letter B, we want to find g prime of -3 and g double prime of -3, but they're also asking us if perhaps it doesn't exist. Uh-oh, we're going to have to think about this one. So g prime of -3. We need to state that g prime equals, g prime of x, equals f of x. So anytime that we want a g prime value, all we have to do is look at the f value. So when we look at g prime of -3, that's the same as f of -3. Where's -3? Right here. Oh, we've got to use our slope knowledge again. This line is when the change of x is 2, the line goes up by 2. So this is going to be the in-between point. So the y value here is 2. Okay, you might have to use a little mental math to figure that out. Sometimes you actually have to use slope to figure it out, but they usually don't make it that hard. So anyway, this y value is 2. And so that means that g prime of -3 equals 2. Would there be any reason this doesn't exist? Nah, it's fine. It's fine. So let's look at g double prime of, same thing, -3. Let's remember that g double prime of x is going to equal f prime of x, right? Second fundamental theorem of calculus told us that these two were equal. So now if I take a derivative of g prime, I get g double prime. Take a derivative of f of x, I get f prime of x. So what is the derivative of f prime of negative 3? Or what is f prime of negative 3? Well, you look at the graph. I mean, I know that f of negative 3 is 2. But how do I find a derivative? Well, here's the thing. Remember that f prime of negative 3 should be the slope of f evaluated at negative 3. What's the slope right here? Well, you do y2 over y1, y2 minus y1 over x2 minus x1, or maybe you can just see the slope, right? So it goes rise over run, right? It goes up 2 over 2. So it has a slope of 1. Okay, again, I just figured out the slope of this line. You know how to do that. I'll let you figure it out on your own. And then, is there any reason why it wouldn't exist? No, it exists just fine. We might get into an issue if they ask us for the second derivative at one of these cusps, but we're okay. Okay? So that's it. You don't even have to address the fact that it does or doesn't exist. So letter C is now asking us about the horizontal tangent lines. And then we also need to find if it's a max or a min and justify our answers. Wow, they threw a lot into this. So here we go. G has a horizontal tangent. Let's go ahead and justify our answer now. G has a horizontal tangent where g prime of x, which equals f of x, equals 0. But that's not all, right? Well, yeah, it is. So g prime of x equals f of x equals 0. That could be, that's going to be your only place that you have a horizontal tangent. And that's all the justification you need, okay, for a horizontal tangent. And when does f of x equals 0? That occurs at -1 and 1. Okay, so x equals 1, x equals -1. Now don't get freaked out. You might think, oh wait, wasn't it from 1 to x, f of t? Wasn't that g of x? So is -1 in it? Yeah, you can plug in a -1 here. Sorry, you can plug in a -1 here and just flip it. So -1 is still in the domain. Okay, so anyway, we have two places where g of x is going to have a horizontal tangent. Now we just have to find out if they're mins or maxes. So -1 is going, the derivative graph, which is f, goes from positive to negative. Therefore, x equals -1 is a max. So let's just write that. X equals -1 is a max. Because g prime of x, which equals f of x, changes from positive to negative. And you're going to write out positive and negative. Okay, and then let's look at x equals -1. And positive 1, sorry. X equals +1. That's not a max nor, that's neither a max nor a min, is it? It goes, the derivative goes from negative to negative. So x equals 1 is neither a max or a min. Because the derivative doesn't change signs, right? Because g prime of x equals f of x does not change signs. That's it. If you know your justification, that one was pretty straightforward. I don't know that we've talked before about the justification for a horizontal tangent is simply that the derivative equals 0.